Other angles.
The preceding section
Yep.
dealt with angles that have their vertices on a circle. Theorem 9 deals with the angle formed by two chords that intersect inside a circle. Such an angle and its vertical angle intersect two arcs.
Okay, so this theorem in this section is first. Last time we had inscribed angles and so forth. This time we're gonna have something a little bit different. Okay, so that's why they say other angles. So take a look at this one right here. It's our first theorem. It says this time you're gonna have two chords in a circle. So the measure of an angle formed by two chords that intersect inside a circle is equal to half the sum of the measure of the intercepted arcs. Okay, it sounds sort of difficult at first, but actually when you look at it, it's not. So take a look at the picture on the right and think about which angles they're talking about. So I'll wait. Go ahead and write it down. And as you write it down, think about what they mean by this. Okay. All right. Who thinks they know what this is talking about? How about Hannah? Over here. What do they mean by, first of all, which angle are they talking about in this picture? It says the measure of an angle formed by two chords.
Angle 2.
Angle 2. Okay, so now that is an angle that's formed by two chords, but it says the measure of angle formed by two chords that intersect. Though. Okay, so which one?
Angle 1.
Yeah, angle 1. They're telling us that if you have two chords intersect in a circle, and you see how it forms an angle 1 here? Okay. In this picture, it's talking about angle 1, right? I could talk about this angle on top, but it works for all these. Okay, so angle 1, right? We could actually figure out the measure of angle 1. What is that equal to? It's saying what? The measure of angle 1 is equal to? Leo, what do you think, sir?
2 plus 3. 2 plus 3.
Oh, that is true. That's actually going to be helpful for us to actually prove one of these, but prove it. But what are they saying? Angle 1 is equal to, it says, half of the sum of the measures of the intercepted arc. So what do they mean by that? First of all, what are the sum of the measure of the intercepted arc of this angle 1 when it gets formed by two chords when they intersect? Okay, first of all, look at the two chords that intersect inside the circle, right? Do you see the two intercepting arc for these two chords? Hint, hint, look at the red one here. What are they? Arc, AC and arc, arc dB, right? So what are they saying? So angle 1 is equal to what? Half of arc AC plus arc dB. Does that make sense? Right? So there's what we have. Now, of course, I could be talking about this angle. Let's say this is, I don't know, A, B, C, D, E, A, E, D, right? Then it will be these chords, right? That angle may be, right? Half of the sum of these chords. But I'm talking about angle 1 right now, okay? I could be talking about this adjacent angle, right? Does that make sense? Still the same way. So, of course, do you understand what he's talking about here? Yes? So if I told you that arc AC was, I don't know, 100 and arc dB, the measure is 60, what would the measure of angle 1 be? Huh? 80, right? You add them together, divided by 2, right? 160 divided by 2 is 80. Does that make sense? That's what they're telling us. That's what this theorem is about. Of course, fun part is to actually try to figure out why this is true, correct? So, do you think this auxiliary line right here, AD, is going to be helpful for us? And what Leo told us is going to be very helpful. What did you say, Leo? That angle 1 is equal to what? Angle 3 plus 2, because angle 1 is the exterior angle of this triangle, right? So go ahead, everybody think about why we get this result. Go ahead. And what Leo told us is going to be important. I'll wait. Okay, so many of you I think got it. Let's see. All right, so just like Leo told us, Leo said measure of angle 1 equals to what? How about Ethan? What did he say?
Measure of angle 3 plus measure.
Yeah, measure of angle 3 plus measure of angle 2. We said that, right? The reason is, of course, because the exterior angle is equal to sum of the remote interior angles. All right, so what? Brandon, over here, what do you think? So what? Can you tell me something about then the arc measure of arc AC.
Measure arc AC
Hmm?
is 2 times measure of angle 2.
Right. Sorry. So, in other words, I should have done the other way. Okay. What about measure of angle 2 equal to?
1/2 of arc AC.
Yeah, 1/2 of that's what I meant. Arc AC. How many people see this?
I do.
Okay. If you don't watch this, let me draw this for you. Look. What kind of angle is this right here? ADC. Inscribed angle. Right. We learned this last time. We got an inscribed angle, and we have the arc that it intersects. Right. So therefore, remember the angle is half of the intersected arc. Right. So we know that's. Now I see another intercepted arc here, other than that one. How about this one right here? You see that? Isn't that another inscribed angle? What can you tell me about measure of angle 3? How about Jonathan?
It's half of
Half of measure of arc. Do I do M first? Doesn't matter. Arc dB, right? Oops, dB. Is that okay? So, just same reason, right, for both of these. Okay, what do we do next? So what? All we have to do then is, Grace, what should we do next? Yeah. What do you think, Grace? So we're looking for measure of angle 1, right? Guess what? We just said measure angle 2 is this, measure angle 3 is this. We substitute in. Tell me what to write. So measure of angle 1 equals then what? Using substitution? Or dB, correct. And of course using, again, another substitution. Or you could say distributive property, right? Backwards, right? Half times what? Measure of AC plus, whoops, half is gone, plus measure of arc, dB is what angle 1 is. And isn't that what the theorem tells us?
Yes.
Okay, there it is. Okay, any question? Does that make sense, guys? Okay, so that's why that works. All right, let's move on to another theorem in this section. Okay, here we go. All right, second theorem. Hannah, can you read this for us?
The measure of an angle formed by two secants
Mm-hmm.
equal to two tangents
Mhm.
or secant and a tangent drawn from a point outside a circle is equal to half the difference of the measures of the intersected arcs.
This sounds sort of difficult. It turns out it's, by the way, how many cases do we have in this case? It says the measure of an angle formed by, first of all, two secants. Remember what secants were? What were secants? Parts of chord, right? Okay, and then two tangents or
Or
secant and a tangent. Drawn from, this is the important part, drawn from where? Point outside a circle. And so people write this down too. It's much easier to have this picture. This is case 1 when you have two secant. Case 2, two tangent. And case 3, secant and a tangent. Even though the picture looks like this tangent doesn't look like it's touching the circle, it is, okay? It's touching the circle at one point. These are two tangents, okay? It's just the print, it didn't print correctly. But does that make sense? And this is the end result. We could actually figure out this angle, right? The point outside the circle that's formed by the two secant, two tangent, or secant and a tangent. It's always equal to half times the difference of these intercepted arcs. Okay? So write that down. Okay? And we'll think about, at least for one of the cases, why this is true. Okay? So for example, look at the case 1 here. Look at case 1. Let's say the measurement of x is 60 degrees, y is 20 degrees. What would the measurement of angle A be? If this is 60, if this is 20? Yeah, 60 minus 20, which is 40, but you have to divide that by 2. So you get 20. Does that make sense? That's what he's saying. What about this case? Let's say this y is 80, and guess what this is? Let's make it easy. Let's say this y is 60. What's this? 300, right? So what would angle 2 be? If this is 60, if this is 300, you do? Yeah, 300 minus 60, which is? 240 divided by 2? So angle 2 is 120. Does that make sense? What about this case? That's all it's saying. Let's say x, the measurement of arc x is 100, y is 40. Okay. So then angle 3 is, well, 100 minus 60, which is, what is it? What did I say? 100 minus 60, which is 40, right? And then 40 divided by 2. Did I say? I said 100 minus.
X was 100.
Uh-huh.
Y was 40.
Oh, y was 40? Oh, my bad. Okay, so x was 100, y was 40. So 100 minus 40 is 60 divided by 2, 30. Okay, does that make sense? That's all it's saying, right? Okay. All right. So if you had to prove this theorem, yes, you got to prove all three cases. Let's just do one of them. Turns out case 2 and 3, you could all do these. Case 1, let's do this one. Let's look at case 1 together. Okay. Here we go. And if time allows, we could talk about case 2 and 3 later, but right now let's just look at the case 1. So let's look at case 1. Okay. So we got this picture. We want to show that angle 1 is equal to half times x minus y. Turns out this could be easily, you could prove this easily. One should draw an auxiliary line. How should I draw an auxiliary line here? Anybody? Guess? Let me give you a hint. You're going to draw an auxiliary line this way. Okay? So if I did this, go ahead and think about how you could show that angle 1 is equal to half of the difference of the x and y. Go ahead, everybody think about as a group. Okay, go ahead, everybody try. See what do you want a hint? Okay, what can you tell me about? I'll give you a hint. Here, listen carefully. What can you tell me about this angle right here? No. Okay, what can you tell me about this angle right up here? It's half of x because you have an inscribed angle, right? So that's a hint. What can you tell me about this angle right here? It's angle right here. Half of y, right? Okay, that's a hint. Go ahead, everybody think about this. Okay, let me tell you one other thing. I think most of you are getting this, but here, let me just draw this on the left side here. And draw that auxiliary line right like this. Okay, this is angle 1 right here, isn't that right? We know what this angle measure is. It's half of x. Okay, we know what this one is. It's half of y. Do you see how we get a triangle right like this?
Yeah.
What is this right here? This angle is d? Okay, go ahead. Maybe that will help. Okay, go ahead, think about this. All right, so I should label this with different, right? Because they're not necessarily the same. All right, so what can we do here? I think a lot of you got it already. This hint really helped, right? How about Josephine? What did your group come up with? So what?
Half x is the exterior angle,
Mm-hmm.
and then the exterior angle is equal to the remote interior angle.
Right, sum of the remote interior angle. So look, very good. So do you guys remember that theorem? We're using this twice already.
Oh.
Half of x, right? That's the exterior angle of this triangle equals to what? Yeah, measurement of angle 1 plus what? Half of y. All right? Well, can you solve for measurement angle 1? Because that's what we're looking for. What's measurement angle 1 equal to? Okay, half x minus
1/2 y.
y. And of course, using the distributive property, we could rewrite this as,
Angle 1 is equal to 1/2 times x minus y.
and that's what we have. Right? Okay, any questions? Does this make sense? Okay, so likewise, you could actually do similar things with these case 2 and 3. Okay, so I will have you think about that. So using all the theorems we learned and so forth, okay, you could actually do case 2 and 3. In order to do case 2, you have to kind of remember something. Let me go over this for now. Okay, hold on. Turns out, in order to show that second case and so forth, you got to remember this. Let's see if you recognize this. Okay, we have a circle. I have a diameter, because it goes to the center. And I have a tangent, right? And we know from the theorem, previous theorem, that it makes 90 degrees. You guys remember that? Okay, because from the radius to tangent, if they meet, that's 90. Let me draw a chord over here. Okay? And let me tell you that this angle measure, no, let's say that, okay, first of all, sure, let me call this angle x degrees. Is that okay? The angle with the tangent and this chord, right? The angle is x degrees. Somebody tell me, what is the measure of this angle that's left over? Very good, that's easy. This is 90 minus x. Did you not agree? If that's true, okay, how about Emily? Can you tell me then, what is the, let me do this in blue. What is the measure of that arc right there? This inscribed angle made. 180 minus 2x. Where'd you get that? You're right. Yeah. Didn't we talk about this theorem last time? Okay, so this angle, this inscribed angle, right, is half of the intercepted arc. So therefore, if this is 90 minus x, it's twice of it. Okay, so let me then ask you this one then. You see this other arc right here? Okay, who can tell me then the measure of that arc? This is pretty straightforward. How about David? Can you tell me what that arc must be? 2x. Where'd you get that? You're right. Well, before you double x, not only that, you know it's half a circle, right? It's half a circle. So, yeah, if you knew the theorem, this is 2x. But guess what I'm trying to prove? That this, right? This, why is this 2x? Because the whole thing is 180. Well, we just figure out that this is 180 minus 2x. Therefore, this has to be 2x, right? When you add them together, it's 180. And now, look at, do you guys remember the theorem about a circle, right? Hold on, let me make this big better. A circle, and you have a, if you have a circle and you have a chord and a tangent. Do you guys remember this from last time? What did we say about this angle measure? That is 1/2 of the intercepted arc. This is 2x. So yesterday I didn't have time to show you why this was true. Here's the reason why. Does that make sense? Okay, it works out, doesn't it? So it turns out if you wanted to show this second case, you need to use that, okay, and so forth. In third case, so all these things that we use, you could actually prove, okay, why this is true. Okay. Any question? Are we good? Here we go. Try this example 1. You have a picture on the right. Okay, because of time, you don't have to copy down the picture, but try to see if you can figure out. It says UT. Do you see UT right here? This segment is tangent to the circle O. I should put O here. Okay, and that if this is true, can you tell me the measure of the arc WT, which is right here? Can you also tell me the angle of TVS? TVS, this angle measure, and angle of RVS, which is right here, RVS, this angle, and RS is, where's RS? Oh, here. So, can you figure out those things out? Go ahead, everybody try. I'll wait. All right, first of all, how do I find WT? Do you see this WT right here? Well, look at, all you have to do is look at this secant and the tangent. Do we know something about secant and the tangent? We just learned this, right? It's this picture, isn't it? Right here. You got a secant and a tangent. Yeah, we know this angle right here that the secant and the tangent make this what? Half of the, half times the difference of these two intercepted arcs. So look, somebody tell me, so we know this angle, they actually tell you the angle, right? So what can we, somebody give me an equation? How about Joshua? Park. Well, we know that this angle is 30 is equal to what? What's the equation? 30 is equal to, Joshua? Half of what? Right, Josh? If you have a secant, you got a secant and a tangent. We just learned this, right? If you have a secant and a tangent, we know this angle 3, right? It goes to half of x minus y, right? So what do? 30 is equal to, they even tell us that angle. 30 is equal to what? Half of? What are the intercepted arc? You see this secant and a tangent? 100, right? 100 minus what? Measure of WT. Correct? Class, what do we get when we do this?
40.
Okay, any question? Comes out to 40, doesn't it, Josh? Does that make sense? All right, then how do you find TWS? TWS, this angle. I mean, sorry, TVS, this angle. So this is using the very first theorem from the, right? We basically then have two chords, right? Intersecting in a circle. What do we know about that? What's this angle going to be? TVS, let's call this TVS equal to what? 1/2 times what? 100 plus 110. Remember this? Isn't that what we have?
Yeah.
Right, that's our first theorem, correct?
Oh, I see.
Right, this is 100, this is 110. Right, we're looking at TVS, remember? That's our first theorem of the day. What does it come out to? Easy enough? You guys remember that? Okay, so this is a nice example. Okay, what about RVS? Oh, that's easy. If this is 105, what's this is 105? Both of these are equal, aren't they? What is it going to be? 75, right? Yeah, because this has to be 75. That's because both of these are 105, right? But these are vertical angles. They're congruent, so it's got to be 75, right? What about RS then? Well, if this is 75, hold on, let's finish up. If this is 75 and we got this on top, right? Which was what? 40? So what's the equation? Hold on, we're not done. What's the equation?
1/2.
Okay, 75 equals to what? 1/2 times, which is what? What's RS? That's what we're looking for, right? Plus what? Which was this? What was WT? Right up here. What was it?
Wait, Mr. Wall, you know what
40.
you know the three other arcs. So each should be 60 minus 110.
Oh yeah, you could do that. Since we know all the other arc, you could just subtract. What does it come out to? Comes out to 75. Or you could add up all the arc, right? Have a great day, guys. Thank you. Okay, so the answer is not 75, but really 110. I made a mistake there. Okay.